Equation of a line passing through 1, 1, 1 point and parallel to z-axis is. And we know that equation of a line passing through x1, y1, z1 and having direction ratios a, b, c is given by x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. So our line is passing through the point 1, 1, 1. So we shall consider x1, y1, z1 as 1 and 1 and 1 and parallel to z-axis. So we can say z-axis direction ratios can be considered to be 0, 0, some constant. So we can write the equation x minus 1 upon 0 is equal to y minus 1 upon 0 is equal to z minus 1 upon some constant k, or we can also write x minus 1 upon 0 is equal to y minus 1 upon 0 is equal to z minus 1 upon dividing with k for all the 3, so we can get 1. So we can go with an option x minus 1 upon 0 is equal to y minus 1 upon 0 is equal to z minus 1 upon 1. So option A is the right answer. Direction ratios of the line 2x minus 4 is equal to 3 minus y upon 4 and z is equal to negative 1. So we can also write it as 2 times of x minus 2 is equal to upon 1 is equal to negative of y minus 3 upon 4 is equal to some lambda constant, and here z plus 1 is equal to 0. So here we can write x minus 2 upon 1 by 2 is equal to y minus 3 upon negative 4 is equal to lambda, and here we can write z minus of minus 1 z minus of minus 1 is equal to 0 into lambda. So we can also write x minus 2 upon 1 upon 2 is equal to y minus 3 upon negative 4 is equal to lambda, and here z minus of minus 1 upon 0 is equal to lambda. Say this is A and say this is B. So from A and B we can write here x minus 2 upon 1 by 2 is equal to y minus 3 upon negative 4 is equal to z minus of minus 1 upon 0 is equal to lambda. So our line equation x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c, which is passing through the point x1, y1, z1 having the direction ratios as a, b and c. So for this line equation we can consider the direction ratios as 1 by 2, negative 4 and 0 just by multiplying with 2. So 1 upon 2 into 2 minus 4 into 2 comma 0 into 2, which are proportionals we can consider. So it is 1 and negative 8 and 0. So we can go with an option 1 comma minus 8 comma 0, option B. Direction ratios of the line x minus 4 is equal to 3 minus y upon 4 and z is equal to 2. So we can write it as x minus 4 upon 1 is equal to negative of y minus 3 upon 4 is equal to say lambda, and we can write z is equal to 2 or z minus 2 is equal to 0 or z minus 2 is equal to 0 times of lambda. So we can write x minus 4 upon 1 is equal to y minus 3 upon negative 4 is equal to lambda, and here z minus 2 upon 0 is equal to lambda. It is 0 into lambda. So we can write z minus 2 upon 0 is lambda. So from these both, say this is A and say this is B. So we can write from A and B x minus 1 x minus 4 upon 1 is equal to y minus 3 upon negative 4 is equal to z minus 2 upon 0 is equal to lambda, which is in the form of a line equation. X minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c, which is passing through the point x1 y1 z1 and having the direction ratios as a comma b comma c. So for this line equation we can say direction ratios as 1 comma minus 4 comma 0. So 1 comma minus 4 comma 0, which is option C. We can go with an option C. Equation of a line passing through origin and parallel to y-axis is, and we know that first equation of a line passing through x1 comma y1 comma z1 and having direction ratios as a comma b comma c is given by x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. So here we can write, since our line is passing through the origin 0 comma 0 comma 0 can be considered as x1 comma y1 comma z1, and the direction ratios of can be considered 0 comma 1 comma 0 0 comma some k comma 0 parallel to y-axis. Since, so we can write the equation as x minus 0 upon 0 is equal to y minus 0 upon some constant k and z minus 0 upon 0, or this can also be written as x minus 0, that is x upon 0, is equal to y minus 0, that is y upon some constant k, is equal to z upon 0, or just dividing with k in the denominator we can write x upon 0 is equal to y upon 1 is equal to z upon 0. So we can go with an option C, x upon 0 is equal to y upon 0 is equal y upon 1 is equal to z upon 0. Assertion and reasoning type question. Direction of a line are the signs of the angle made by the line with the negative direction of the coordinate axis. Actually we have direction cosines of a line, or direction of a line are the cosine of the angles. We'll consider cosine of the angles made by the line with the positive direction of coordinate axis. The x-axis, y-axis and z-axis. And if a line is made, if this is a line, then with the positive direction of x-axis, if it makes an angle alpha, and with positive direction of y-axis, if it makes an angle beta, and with the positive direction of axis z-axis, if it makes an angle gamma, then cos alpha, cos beta and cos gamma are called the direction cosines, or direction of a line. But it is given direction of a line are the signs of the angle made by the line with the negative direction of x-axis, so which is false. So we can say assertion is false. And second reason are, if the lines x minus x1 upon a1 is equal to y minus y1 upon b1 is equal to z minus z1 upon c1, and another line x minus x2 upon a2 is equal to y minus y2 upon b2 is equal to z minus z2 upon c2, having the direction ratios here a1 b1 c1 and here a2 b2 and c2, and we can find the angle between them as a1 a2 plus, so we have cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. And when in the case of perpendicular, we can say cos 90, which is 0. So we can use the condition a1 a2 plus b1 b2 plus c1 c2 is equal to 0 when theta is equal to 90 degrees. So we can say that this condition is correct when two lines are perpendicular. So reason is true. So we can go with an option. Assertion is false and reason is true. So option D. Cartesian equation of a line are given. X is equal to ay plus b and z is equal to cy plus d, and its direction ratios are given. And we know that a line which is passing through the point x1 comma y1 comma z1 and having the direction ratios as a b c is given by x minus x1 upon a is equal to y minus y1 upon b is equal to z minus z1 upon c. So here the direction ratios are a comma b comma c, and here we can write x minus b upon a is equal to y, and here z minus d upon c is equal to y. So we can also write x minus b upon a is equal to y is equal to z minus d upon c. So which can also be written x minus b upon a is equal to y minus 0 upon 1 is equal to z minus d upon c, which is in the line equation form. So here we can say the direction ratios of this line as a comma 1 comma c. So we can go with an option B. Assertion and reasoning type question. Assertion: the angle between two lines whose direction ratios are proportional to 112 and root 3 minus 1 comma minus root 3 minus 1 comma 4 is pi by 3. And since we know that if the lines are having direction ratios a1 comma b1 comma c1 and a2 comma b2 comma c2, then we have cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 upon root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. So we can use here cos theta is equal to, since direction ratios are given, say a1 b1 c1 as 112 and 1 into, and here we can say a2 b2 and c2. So a1 a2, that is 1 times of root 3 minus 1. So let me write here 1 times of root 3 minus 1, and again plus 1 times of minus root 3 minus 1 plus 2 times of 4 upon root of 1 square plus 1 square plus 2 square into root of root 3 minus 1 whole square plus negative root 3 minus 1 whole square plus 4 square, which is equal to root 3 minus 1 minus root 3 minus 1 plus 8. So root 3 get cancelled, and we can use here divided by root of 4 plus 1 plus 1, that is 6. And again here we can use root 3 minus 1 whole square is 3 plus 1 minus 2 root 3, and here negative root 3 minus 1 whole square we can add root 3 plus 1 whole square, that is 3 plus 1 plus 2 root 3 plus 4 square is 16. So we can add 8 minus 2, this is 6 upon root 6 into, and here it comes negative 2 root 3 and positive 2 root 3 gets cancelled, and 3 plus 1 4, 4 plus 4 8, 8 plus 16, 16 plus 8 is 24. So 4 plus 4 is 8, 8 plus 16 is 24. Or we can add 6 upon root 6 into root 24, we can add root 4 into root 6. 6 and root 6 gets cancelled, so it is 1 upon 2. So we can say cos theta is equal to 1 upon 2. So cos 60 is 1 by 2. So theta is equal to pi by 3. So we can say that the assertion is true. And reason, let us see the reason. Angle between the two lines, when in vector form, r is equal to a1 plus some lambda times of vector m1, and r is equal to a2 plus mu times of m2. So these are two different lines passing through two different points, a1 having position vectors a1 and a2, and direction ratios are given as m1 and m2. So these are m1 and m2. So we have cos theta is equal to m1 dot m2 upon mod of m1 into mod of m2, which is the right formula to find the angle. So we can use, by using this, m1 m2 is nothing but direction ratios just like a1 b1 c1 and a2 b2 c2 for the two lines. So we can say the dot product of this, we will get a1 a2 plus b1 b2 plus c1 c2, and mod divided with mod of m1 and mod of m2 is similar to root of a1 square plus b1 square plus c1 square, root of a2 square plus b2 square plus c2 square. So we can say that this reason is correct, and this is the correct explanation for the assertion. So we can say both A and R are true, and R is the correct explanation of A. So we can go with an option A, but it is given in the vector form.